Hello 7th graders, welcome to lesson 9.1. I can identify arithmetic sequences. After you're able to identify arithmetic sequences, you'll then be able to write an expression to find the nth term in an arithmetic sequence. So find any number at the same change. This is starting on page 464 in your textbook. Arithmetic sequences, we're going to look and we're going to first consider this following pattern. We're going to look at this pattern of toothpicks. Notice the number of triangles. To make one triangle, it takes 3 toothpicks. To make 2 triangles, it takes 5. And 3, it takes 7. So what we notice is that for every 1 triangle, we have an additional 2 toothpicks after the beginning 3 toothpicks. And so what this means for us is that the number of toothpicks needed for each pattern form a sequence. A sequence is an ordered list of numbers. Okay, so an ordered list of numbers. Each number in the list is called a term. We talked about term a little bit before. An arithmetic sequence is a sequence in which the difference from one term to the next is the same. And the difference, these are adding differences. So you can either add a positive or you can add a negative, but it's some sort of addition, not multiplication. That's something different. So, for example, 3 to 5 to 7 to 9 to 11, the common difference between every triangle is two toothpicks, and therefore this is called our common, since it's the same, it's called our common difference. So we're going to be able to identify if the sequence is arithmetic or not. So if there is an adding pattern, that's how you decide. So again, if it's an adding pattern, adding a positive or negative. If you do see an adding pattern, then you're going to state the common difference. You usually do common difference and then whatever you're going up or down by. And then saying the next 3 terms. So say the pattern were to continue, what would the next 3 numbers in the sequence be? So notice here these numbers, we list them in the order they are, 17, 12, 7, 2, negative 3. And we notice that we're going down, so you assume that you are adding a negative, which is the same as subtracting 5. So adding a negative 5 or subtracting 5. So we go down 5, down 5, down 5, down 5. And so on. So if we wanted to find the next 3 terms, they have a common difference of negative 5. So the sequence is arithmetic because there is that adding pattern. And you continue the pattern to find the next 3 terms. So negative 3 minus 5 would be negative 8. Negative 8 minus 5 would be negative 13. And negative 13 minus 5 would be negative 18. And then the pattern would continue, but in this case we were only asked to find the next 3 terms. So on these next 2 examples, you can check them and come back, or follow A and then look at B. So we're going to state whether each sequence is arithmetic, so we have to decide yes or no. Is there an adding pattern? And then decide yes or no. If it is, then we'll decide the common difference, and we'll write the next 3 terms. So I look, and what I'm going to have in here, I don't know why I wrote tables, I shouldn't have. I'm going to list 2, 6, 10, 14, 18. You don't need the table in your notes. And I'm going to look what the difference is. It looks like this one's going up by 4, up by 4, up by 4. This is how you'd like to show your work. Up by 4. So since this one is going up by 4 every time, this is a yes. This is an arithmetic sequence because there is a common difference, and you'd write your common difference as plus 4. On the other side, we have a negative 4, negative 8, negative 16, negative 32. Notice I'm going down 4, but then I go down 8, down 16. So because these are not the same difference in adding, sure, we may be multiplying by 2, but that is not arithmetic where we do an adding or adding a negative difference. So because this is a no because it is not arithmetic because there is not a common difference. No common difference. You're not adding or subtracting the same number every time. So if we were to describe Hello, that got crazy. Describe an arithmetic sequence. If you want to write an expression that can be used to find the nth term, meaning any number, if you wanted to find the 100th term in the sequence, the 7th term, any number in the order, then you can make a table to do that. So, this case, they're wanting us to write an expression that can be used to find the nth term of the sequence of the perimeter of squares. So, perimeter of a 1 unit square would be 4, 8, and then 12, and then 16. So, we're going to write the next 3 terms, but we're going to use a table to help us. So, in a table that you create, you start at the top is your term. So, like the first number is your first term. The second number is your second term. The third number is your third term, and so on. So, the first number, the first term, was 4, had a perimeter of 4. Second square had a perimeter of 8. Third had 12, and the fourth had 16. So you notice that you're going up by 1 every square, every term. While you're going up every term, you're going up by 4 in the perimeter. So you look, the terms have a common difference. I'm trying to erase that. The terms have a common difference of 4. So they're going up by 4 every time, common difference of 4. Also, each term is 4 times its term number, meaning 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12, 4 times 4 is 16. An expression that can be used to find the nth term is 4n. So if we wanted to find out what the perimeter of the 5th square would be, then we do 4 times 5, and we get 20. 4 times the 6th term, 6th square is 24, 4 times the 7th, and 28. Say you were curious and you wanted to know what the 10th square was. So you do 4 times n, which in this case we're going to do 10, and you'd end up with a perimeter of 40, and so on. Thing about equations and expressions is they allow you to find anything when you plug in the variable. So let's do that same thing, making a table and writing the expression to the nth term. So we're going to write an expression like we did above, writing an expression to find the nth term and then find the next 3. So in the top we're going to have, this is our term, which is n, and the number of the outcome. So this is our first term, second term, third term, fourth term. So our first one, we got a -2. Our second was -4. Our third was -6. And our fourth was -8. So what we see is that we're going down by 2 every time. And -2 times each one is going to get us there. So we can do -2n is our expression. So if we want to find our next 3 terms, like we want to find our 5th term, we're going to do -2 times 5, which is -10. Do -2 times 6, which is -12. -2 times 7, which is -14. Over here, we'll do the same thing. Our term, which is n, and the number that comes out. First term is 1/6, second term is 1/3, third term is 1/2, and the fourth term is 2/3. If you are unable to be able to tell the difference on this, since we know that we should be adding going forward, what you can do is subtract going backwards. So to find it, I'm going to do, well, 1/3 minus 1/6, and I'd have to do some, change this to 2/6 minus 1/6, and I end up with 1/6. That's going to be a pattern if it's the same on the next one. So if I did 1/2 minus 1/3, I'm working backwards, and again I got 3/6 minus 2/6, I end up at 1/6. So I see that my common difference is 1/6. It's like my common difference here was -2. My common difference is 1/6 on this one, which was a little harder. So I used my inverse to find. So if I want my 5th term, my expression, first of all, is going to be 1/6 times the number n. So 1/6 times 5 gives me 5/6. 1/6 times 6 gives me 1. And 1/6 times my next term of 7 gives me 1 and 1/6. Text messaging, some real world example here. Real world example says that the table shows the monthly cost of sending a text message. How much would it cost to send 60 text messages? So we look at our table, and this is in your book, page 465, and we look at the number of messages sent and what it costs. So we notice that we're going up 10 cents for every message, one message sent. So what this means is the common difference between the costs is 10 cents. It implies that the expression for the nth term is 10 cents n, where n represents the number of messages. So 10 cents per message. So we can use this to compare the cost of each message. Each cost is $10 more than 10 cents per message. So the expression plus 10 is the cost of n messages. To find the cost of sending 60 messages, let C represent the cost and write and solve an equation for n equals 60. Notice the difference was 10, that's where they got that. They started on their starting number. So if we just did multiply by 10, what they mean more specifically, is this is just the cost of the messages, that we must have a $10 starting fee as well, like monthly fee. So that's why we do 10 cents per message plus a $10 say monthly fee. So then we plug in C for our messages and add 10. So we get 6 plus 10 or 16. What that means is it would cost $16 to send 60 messages on this cell phone plan. So again, write and solve an expression to find the nth term. So we can do these ones. Of the arithmetic sequences. So we're going to first fill in our table. We have our term, the number, and we have the number we're trying to get out. First term is 4, second term was 9, third term is 14, fourth term was 19. They want us to find the nth term, but first we have to find our common difference. So we look. We're going up by 5, up by 5, up by 5. So our common difference is plus 5. And notice that we had a where would we start. So we get a sequence of 5n minus 1. Because for the reason that it's minus 1 is where would we have started? We did plus 5 here. Really subtract 5 from 4, and that means at the 0 term where we didn't start, we would have had a negative 1 before we added that first 5. So that's going to be our expression. We'll talk a little bit more about that. So to find our nth term of 12, then you do 5 times 12 minus 1, which would be 60 minus 1, which is the nth term of 12. The 12th term in that sequence is 59. Next one, same thing. Do the term and the number. This is n, remember. First term, negative 20. Second term, negative 16. Third, negative 12. Fourth, negative 8. They want us to find the 20th, so way over here. So we look, our common difference, looks like we're going down, or we're going up, sorry. Going up by 4. So our common difference is going up by 4. Notice though, where would we have started before at our 0 term? So we would say, okay, take 4 away from 20, and we'd be at negative 24. So our expression would be 4 times the number we're looking for minus 24 where we started. Then we want to plug in, find our 20th term. So we do 4 times 20 minus 24. So we get 80 minus 24, which is equal to 56. So the 20th term in the sequence, if we're going up by 4, will end up at 56. Last one, a little test example, practice multiple choice. Which expression can be used to find the nth term in the following sequence, where n represents the number position in the sequence? Okay, so position in the sequence, and we want to find this number. So again, look for your pattern. It looks like we're going up +2 for every one of these. If we went down 2, at 0, we would have started at 1. So it looks like we're going 2 for every n after we start at 1 for an answer C. All right, ladies and gentlemen, for extra understanding, better understanding, rewatch the video. Whoop. Rewatch the video, read examples in the book, personal tutor, online textbook, lots of places for you to go. Best wishes to you.